Assalamualaikum and very good evening to everyone. My name is Muhammad Akmal and today I will be presenting about chemical accident in Malaysia. Thank you for taking your time to join my presentation. The purpose of this presentation is to help us better understanding the chemical accident in Malaysia. By the end of the season, I hope you will gain clear insight into this incident. Our team member is Muhammad Danish bin Muhammad Najib, Muhammad Akmal Hisham bin Baharudin, Muhammad Akmal bin Mat Soleh, that's me, Muhammad Akil Haikal bin Muhammad Hafizuddin. This is our scope of case study: ammonia gas cylinder explosion. There is 8 chemicals industry in Malaysia. The 5th point is our incident. It's an industrial gas. Case study 1. Gas ammonia cylinders explosion. The chronology. On 8 August 2015 at 4:45 p.m, ammonia gas cylinder exploded at Sungai Besi, Kuala Lumpur, Malaysia. It involved 7 cylinders. 4 of the cylinder was in reclining position. Most of the cylinder were older than 20 years old, which means it was expired. A worker was killed by the explosion. There is 4 major weaknesses of safety management in this incident. The first is lack of safety guidance from a safety officer. This is a not good sign of the incident. The last, failure in risk assessment and risk control. As you guys can see, this is a incident photo at the gas ammonia cylinder explosion in Sungai Besi, Kuala Lumpur. The gas was positioned in horizontal position, which means this is not allowed.
Hello, my name is Muhammad Akil Haikal. Today I want to speak about FMEA table. First, during acceptance stage, the problem like wrong inspection or unnoticed damage can happen. This can cause major gas leakage. To prevent this, we need to follow the correct inspection SOP and make sure cylinders are checked carefully. Next, in the storage section, issue such as correction or cylinder degradation may occur. This problem can also lead to leakage. We already have visual check and maintenance log, but we should improve storage arrangement and make inspection more consistent. For the operation stage, the main failure is wrong regulation connection or using the wrong equipment. This can cause gas to leak or the system to malfunction. To reduce the risk, we need better operator training, proper labeling and regular equipment calibration. Overall, the highest risk we found is during equipment installation, where wrong fitting can lead to serious leakage. This area needs the most attention. Chemical safety legislation in Malaysia. Register and control of chemical hazardous and health OSH. Use and standard of exposure of chemical hazardous to health regulation 2000. Chemical register to be kept at the workplace. Inventory or hazardous chemical OSH. Classification, labeling and safety data sheet of hazardous chemical regulation 2030. Chemical Information Management System. Prevention of major chemical accident or control of major industrial hazard regulation 1990. Notification of chemical accident or notification of accident, dangerous occupation, poison and disease regulation 2004.
Hi, my name is Muhammad Akmal Hisham bin Baharudin. My part is Section C MSDS analysis. 5 major chemicals involved in the case. First, anhydrous ammonia. Second, H2O from ammonia water solution formation. Third, ammonia hydroxide. Fourth, lubricating oil compressor equipment oil. Fifth, nitrogen gas. 2.0 official MSDS safety data sheet for each chemical. This is the website manufacturing. We have the 4 anhydrous ammonia, compressor oil and nitrogen. Section C 3.0 MSDS analysis. This is for the chemical hazard class. Signal word exposure limits, we have the 5 chemical: anhydrous ammonia, ammonium hydroxide, compressed oil, nitrogen and water H2O. Section C 3.1, anhydrous ammonia poses the highest risk to human health in this incident. Why the anhydrous ammonia is the highest risk chemical? Reasoning is acute inhalation toxicity is very high. Second, high volatility and rapid dispersion as a gas. Potential for mass casualties from a single release. Compounding factor in explosion fracture scenario.
Assalamualaikum. My name is Muhammad Danish bin Muhammad Najib. I will present about safety improvement and prevention plan. Most of the incident record were caused by negligence and improper handling procedure. Therefore, this plan focus on improving safety practice, enhancing preventive measure, and ensuring that worker remain proactive and vigilant to avoid recurrence of similar incidents. From the FMEA assessment, several important findings were identified. First, high risk failure mode identification. From the FMEA assessment, several important findings were identified. First, high risk failure modes identified. Second, root cause human error, poor inspection, inadequate ventilation, and material degradations. Most critical RPNs like to cylinders, connection, storage, and maintenance. Second, key finding from MSDS. First, hazard chemical, ammonia, ammonium hydroxide, compressor, oil, nitrogen. Second, main hazard, toxicity, skin irritation, fire explosion risk. Last, require control, proper PPA ventilation, spill control, emergency first aid. Our safety enhancement plan consists of several layers. First, engineering controls. Install fixed gas detector, improve ventilation in storage and missing area, upgrade regulator, hose and valve system based on FMEA's findings. PPA improvement. Respiratory protection in confined or poorly ventilation space. Second, chemical resistant glove, goggles, apron for ammonia handling. Last, flame resistant clothing for hot water. Last, administrative controls. Strict SOP for cylinder connection and maintenance. Schedule inspection aligned with FMEA high risk points. Last, hot work permit enforcement in fire risk zone PP improve. We also strengthened our emergency response measure by first emergency response adjustments. Spill kits located near high-risk areas. Update evacuation plan for ammonia leaks. Last, clear labeling with MSDS sheet available. We also strengthen our emergency response measure by first emergency response adjustments. Spill kits located near high-risk area. Update evacuation plan for ammonia leaks. Clear labeling with MSDS sheet availability at all workstations. So far, expected outcome. The safety improvement have reduced the likelihood of high RPN failure and lower worker exposure to hazardous chemical. This action also increase overall safety awareness among workers and ensure better compliance with industry safety standard. This photo show example of improvement implement. First, as we can see, there are digital weighting scale for accurate cylinder measurement. Second, we have record system to track cylinder condition and movement. So third, we have ammonia piping and clear identification. The last pipe for excess gas to prevent pressure build up. This upgrade support safer operation and reduce human error. In conclusion, most of the accidents were caused by negligence. Ensure safety working procedures and measures are in place and must be proactive and vigilant to avoid the reoccurrence of the accidents.